Hello everyone. In this video, I'm going to explain what is a differential equation and how do we solve them. So any equation that contains a derivative is called a differential equation. For example, dy over dx equals to 3x squared. Now the question arises, how do we solve a differential equation? So step 1 for solving an differential equation is that we put the equation into differential form. So we separate out the differential of y and differential of x. So basically we split the derivative. So for example, this equation, we're going to write this as dy is equal to 3x squared dx. So we have separated the variable x on one side and y on other side. So step 2 is we integrate both sides of this new equation. So we get integral of dy is equal to integral of 3x squared dx, and then we solve this integral. So integral of dy is y plus c1. So 3 times integral of x squared is x cubed over 3 plus c2. And now we notice that we get something y is equal to, so x cubed, and we can combine the constants together. So together this gives us a new constant. So you can only write the constant once. So you don't need to write c1, c2. You can just write the constant in the end. So you could have just done y is equal to x cubed plus c. So this is the solution of our differential equation dy over dx that was given in the beginning. So dy over dx equals to 3x squared. So we're going to follow the same steps for other differential examples that we are going to do in this video. So let's try another example. Solve this differential equation. So first I'm going to rewrite this differential equation. So dy over dx, in place of f prime x, I'm writing in terms of dy over dx minus 2 pi e raised to power 3x equals to 0. So this is basically the same thing. So now from here we notice that dy over dx is 2 pi e raised to power 3x. So next step is we split the derivative and we separate the variables. So this implies differential of y. So dy is equal to 2 pi e raised to power 3x dx. And now is a step where we integrate because we have already separated the variables. So when we do the integral, so from here we get y, and here 2 pi is a constant. So e raised to power 3x dx. Integral of e raised to power 3x dx. So we have done the exponential form. So we know that. So you can use this as u substitution. So if you use u equals to 3x, so du is 3 dx, or dx is du over 3. And remember, so I told you that trick. So you have e raised to power some function and differential of the function. So also we can divide by 3. So we get that form. E raised to power formula. So e raised to power fx f prime x dx. So the answer is e raised to power fx plus c. So we have exact same thing here. So function is 3x, differential of the function is 3 dx, so we get 2 pi over 3 e raised to power 3x plus c. So that is our required solution of the given differential equation. And sometimes you are given some conditions, so in those cases you can solve for c. So we can solve for c if we know something about the function, some additional information. All right, so let's try next problem. So we need to solve this differential equation, and also here you will notice that we are given some information about the function a. So it says that when, so it means when t is 2, the value of a is 2 over 3. So we're going to use this to find c in the end. So use this to find c. So let's start with our solution of this equation. So first step is separate the variables. So dA is equals to 4 over 3t minus 5 dt. And now, so we have separated the variables. So now is a good time to take the integral on both sides. So from here we get a is equal to, so 4 is a constant. So integral of 1 over 3t minus 5 dt. And now if we think of 3t minus 5 as our function, or you can use the substitution, so you can do all the steps like u is equal to 3t minus 5, du is equal to 3t dt. Oh, sorry, 3 dt. So in this case, I'm just going to use a shortcut method. So I taught you guys that if you have 1 over fx and differential of the function with u, so then we can write this as ln of fx plus c. So in this case, the differential of 3t minus 5 is 3 dt, so it means we need a 3 here. So I'm going to multiply by 3 and divide by 3. So from here I got a is equal to 4 over 3 ln of 3t minus 5 plus c. So now we're going to solve for our C because we have some additional information. So when t is 2, a is 2 over 3. So at is 2 over 3 when t is 2. So 3 times 2 minus 5 plus c. So 2 over 3, 4 over 3. So ln of 6 minus 5, which is ln of 1 plus c, and we know that ln 1 is 0. So in this case this whole thing becomes 0. So from here we get c is equals to 2 over 3. So c is 2 over 3. So let's put this value of c in our original equation. So we get a is equal to, so a is equal to 4 over 3 ln of 3t minus 5 plus 2 over 3. So that is our required solution of given differential equation with a boundary condition. So we are given a condition that when t is 2, a is 2 over 3. So this is the required solution. So sometimes you are given some additional information in the question that you can use to find your constant value. So let's talk about differential equations with boundary or initial conditions. A boundary or initial condition allows us to solve for C. So it's just that additional piece of information that help us to find C. So let's take a look at this problem. So find the function. So we need to find fx, and we are given the derivative. So we are given the differential equation. So we are given dy over dx is 3x, and also we know this information that the function goes through point 2, 0. So it means when x is 2, the value of the function 0. So that's what it means. All right, so let's start solving our equation. So first step is separate the variables. So once you have separated the variables, now is a good time to take the integral on both sides. So taking the integral of dy, we get y is equal to 3x squared over 2 plus c. So now f2 equals to 0. So let's use our condition. So this condition tells us that, so when x is 2, y is 0. So it means this equation is like this, and from here we got that 0 is equal to, so one of the two cancels, so 6 plus c, and c is equal to -6. So now we plug back the value here, so it means our equation becomes y is equal to 3x squared over 2 plus c. So in place of c I'm going to write -6. So that is our required function. So required function which satisfy all the conditions. So far we just discussed that if we have something like first order differential equation. So first order derivative in the equation, so we get fx plus some constant. But what if you have something like second order differential equation, so second derivative? So in this case, if you integrate it once, so you're gonna get f prime x plus c1 as your answer. But then you have to take the integral of this equation again. So if you take integral of this equation again, so you will get, so let's take the integral of, okay, so I'm just going to write here integrate again. So that means double integral of f double prime dx, and I'm replacing this piece with what we got in the previous question. So integral of f prime x plus c1. So in this case, integral of f prime x is just fx, and for c1, which is a constant, so c1x, and then there will be another constant c2. So each step of integration generates a constant, so we need to determine the constant before further integration. So if you have a problem where you are given two conditions, so you first figure out this value and then integrate again and then solve further. So just keep in mind, so if you have higher order differential equations, so each step of integration generates a constant, and you need to determine the constant before the further integration. I hope that makes sense. So in the next video, I will explain some application problems of differential equations. So please do watch that video as well. Thanks for watching. See you next time.